NASA Space Story number 998. 4 minutes 30 seconds. 3, 2, 1.
This is the Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. 6,000 tons of steel have been properly positioned. A new 135,000 horsepower drive system is in place, and 6 large fans, each measuring 40 feet in diameter, are ready to roll. All of which means that modifications of the wind tunnel facility at NASA's Ames Research Center have been completed, and soon aeronautical researchers will again be able to take advantage of this valuable tool. In addition to increasing the wind speed capability of an existing tunnel, the revamping project also included the construction of what is now the largest wind tunnel test section in the world. Wind tunnels are essentially large wind machines used to test representative models of various aircraft concepts, and even full-scale airplanes and spacecraft. Mike Filarski, Assistant Chief of the Low-Speed Wind Tunnel Investigations Branch at Ames, outlines their importance.
Wind tunnels are a very important research tool in the aeronautical field because it's much easier and less expensive and safer to build a model of an aircraft concept and test it in the wind tunnel than it is to build an actual flight hardware. In the wind tunnel, you don't have to worry about hurting anyone, really. Like in an aircraft, you have to be concerned about safety because you have people flying in the airplane. In the wind tunnel, we don't have people in the airplane. We can build them cheaper because we don't have to build them to flight weight.
A number of potential problems have been avoided by past wind tunnel testing. Again, Mike Filarski.
We have discovered in testing various concepts, flaws in the design, which would have in an aircraft caused it to crash probably, or had been very difficult to control. In fact, we have also, had failures in the wind tunnel. We have had rotor systems come apart that we were testing for advanced helicopter concepts because we did not understand completely the dynamics of the rotor. We've also had aircraft fail because of misunderstandings of loading. We've also discovered, instabilities in aircraft concepts that would not have, been controllable.
Other devices have also been tested in the Ames wind tunnels.
Because we are a large wind tunnel, we have tested things like heliostats, which is a large mirror that they're using for solar research. They could not predict adequately the drag or the loading on one of these mirrors when it's setting out in the desert. So they brought one into our wind tunnel and mounted it in the wind tunnel, and we tested it to measure the loads that an outside wind would impact on it with. We've also tested such things as radar antenna for the same reason. Tents, inflatable shelters that the Army wanted to use. We tested the space shuttle in the 40 by 80 several years ago, a 1/3 scale model of the space shuttle, to investigate its landing characteristics. The space shuttle is designed as a space vehicle primarily, but it also has to land in a normal, typical runway. And so we installed a model of the space shuttle in the 40 by 80 and tested it through the low-speed flight regime. In other words, from 200 knots down to basically 0, to make sure that the flaps and ailerons and controls would work adequately, when it was landing, and it performed very well, very close to predicted. So we've tested a variety of things in the wind tunnel other than aircraft, but our primary function is, research and development of advanced aircraft concepts.
Wind tunnels, providing an inexpensive, safe way of testing aerodynamic concepts to ensure stability in aircraft construction. This has been The Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration.
NASA Space Story number 999. 4 minutes, 30 seconds. In 3, 2, 1.
This is The Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. What seems to be the process of looking out into space may actually be that of looking back in time, according to astronomical researchers interested in the evolution of galaxies. The key here is the relationship between the speed of light and the great distances these galaxies are from our planet. Just as the light we are receiving now actually emanated from the Sun 8 minutes ago, so the light creating our view of a distant galaxy may have been in transit for as long as 10 billion years. Dr. Hyron Spinrad, a professor of astronomy at the University of California at Berkeley, outlined the significance of this phenomenon.
If you look at a very distant galaxy, measure its properties, which of course is a difficult technical task, you see the galaxy as it was 10 billion years ago. So you can see it as it was when it was much younger. And then compare it to a galaxy of the same sort near us, then if that is accomplished well enough, you can look at the systematic changes in the properties of galaxies over a good fraction of their lifetimes. These galaxies, like stars and like people, evolve with time. They don't stand still. They change. They are born and live and then somehow perhaps even die.
Dr. Spinrad also described the instrumentation or methods used to measure these galactic properties.
Most of the work I'm doing uses advanced optical instrumentation, but sometimes finding the galaxy requires getting its position from some other technique. For example, radio astronomy yields positions of radio sources, and a fraction of those are distant radio galaxies, large galaxies with extreme nuclear activity, explosive type activity, which earmarks them for study and makes them easier to find. But the work I'm doing specifically myself on either radio galaxies or just normal distant faint galaxies is to measure their spectral properties. There is their colors when you break up the light into the constituent spectrum with a grating or prism. You can learn something about the speed of the galaxy moving away from you in the general expansion of the universe, and you can measure some of the properties of the stars that compose it, what they're made of and how hot they are, things like that.
NASA's International Ultraviolet Explorer satellite has also proven useful, but only in determining the characteristics of nearer, more mature galaxies. However, astronomical researchers hope that the Space Telescope, scheduled to be deployed by the Space Shuttle in May of 1985, will greatly enhance their observing capabilities. Even from the evidence gathered to date, though, certain patterns seem to be emerging. Again, Dr. Spinrad.
Galaxies nearby and galaxies far away are systematically a little different, presumably because of age, and the difference manifests itself in the way the stars are accumulated. The distant ones, seen as younger objects, do have some more massive stars in them than the nearby ones, and the difference is just a matter of time. As time goes on, the big ones gradually evolve away, finish their nuclear fuel, and go to some stellar graveyard. The secondary effect is distant galaxies are more active, have more hot ionized gas, as it's called, in their centers than do nearby analogs of the same kind of galaxy. And therefore, that presumably means that the fuel supply available for galactic activity may have been somewhat more plentiful back 10 billion years than it is right now.
Investigating the evolution of galaxies, helping us better understand the universe we live in. This has been The Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration.
NASA Space Story number 1000, 4 minutes and 30 seconds. 3, 2, 1.
This is the Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. Named after the man who first observed the planet Jupiter and its moons through a primitive telescope nearly 375 years ago, NASA's Galileo spacecraft, being developed at the Jet Propulsion Laboratory in California, is designed to provide far more detailed information on this same Jovian system. Dr. Torrence Johnson, project scientist for Galileo, described its purpose.
The Galileo, or Project Galileo, is our next major interplanetary mission. It's designed to be a thorough exploration of the entire Jupiter system, including the atmosphere of Jupiter, the moons around Jupiter, and the magnetospheric particles and fields environment which surrounds the whole system and interacts with the whole system. It's designed to be the next really major step after the Voyager reconnaissance. Voyager gave us, in effect, a snapshot of the system, the first look, if you will, at a number of the different aspects of Jupiter and its environment. What we're going to do with Galileo is get in there, get a lot closer, going to be able to probe the atmosphere of Jupiter directly. We're going to be able to stay in orbit around Jupiter for nearly 2 years. So this will allow us to, for the first time, really sample the atmosphere of Jupiter with direct chemical measurements, very similar to the ones that were carried to Venus by the Pioneer Venus program. Most of the scientists studying the solar system today believe that Jupiter, in effect, captured a lot of the original material that the whole solar system formed out of, and it's been relatively unmodified in Jupiter since then. So this will be our first real look at sort of the original star stuff that everything in the solar system was formed out of. Again, Voyager gave us a snapshot, a very complicated, fascinating, continually changing system. With Galileo, we'll be able to sit there and monitor that system, see what makes it go. And I think we're going to uncover some things that are just as surprising compared to what we know now as Voyager uncovered compared to our previous telescopic information.
Dr. Johnson is particularly interested in the information Galileo will gather regarding Jupiter's moons or satellites, information which could shed light upon the development of the solar system.
Jupiter acted in its early formation intervals much like the Sun did for the planets, and affected the very composition and the nature of the satellites as we see them now. So that by looking at the satellites, what their compositions are, what their evolution has been, we're effectively looking back in time into this evolutionary period of the Jovian system, which was in effect a miniature solar system.
Currently scheduled to be launched in May 1986, Galileo will be the first planetary spacecraft to use the new space transportation system. Again, Dr. Johnson.
The shuttle will take the Galileo spacecraft and an upper stage rocket, probably the Centaur rocket, up in its cargo bay into Earth orbit. When the shuttle gets into orbit, it'll open the cargo bay doors. The combination of the upper stage rocket and the Galileo spacecraft will be erected from the cargo bay and pushed off gently into space. The shuttle, the spaceship itself, will move away from the vicinity. When it's safely away, the upper stage Centaur rocket will ignite and send the spacecraft on from that point in Earth orbit into the interplanetary trajectory necessary to get to Jupiter. It'll arrive there approximately a little over 2 years later in 1988.
The Galileo project, taking in-depth exploration of the solar system one step further. This has been The Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration.
NASA Space Story number 1001. 4 minutes, 30 seconds. 3, 2, 1.
This is The Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. Mapping the vast solar system, an unenviable task, but one which the United States, the United Kingdom, and the Netherlands hope will be more readily accomplished once the result of their joint undertaking, the Infrared Astronomical Satellite, or IRAS, is launched into sun-synchronous orbit in January 1983. One focus of this satellite's varied mission is the thousands of sun-orbiting asteroids scattered throughout the solar system. Dr. Dennis Matson, a research scientist and group supervisor at NASA's Jet Propulsion Laboratory, explained the importance of investigating asteroids.
There are a variety of reasons why one wants to study asteroids, from reasons that are purely scientific to reasons that are more practical. On the scientific plane, the asteroids are members of the solar system, and as we explore the solar system, there are objects that we want to discover. We want to know where their orbits are. We want to know what they are made out of and how they fit into the overall story of how the solar system evolved and what its past history has been. On the more practical level, asteroids also come close to the Earth. They go by the Earth and the Moon, and you can see on the surface of the Moon the record of cratering that occurred when objects of this type in the past have collided with the Moon. Collisions of that type have also occurred on the Earth. And one would like to know how many objects are coming by the Earth and what is the probability that they might strike the Earth at some time in the distant future. In principle, this is information which can be gained by discovering where asteroids are and what their orbits are, and from that you can predict where they will be in the future. Now, IRAS will not by itself yield orbits on these asteroids, but it will provide physical information that tells us their size and their reflectivities when we learn their orbits by other means. Sometime several decades from now, asteroids may play an economic role, as they have certain minerals and rocks on their surfaces and composing their interiors. Some of these objects will have minerals that have economic value. If those asteroids come close enough to the Earth, the possibility of mining them is something that will be undertaken at some point in the future. That's not something that will happen in the next decade or in the next 30 years. But when you speak about the next century, that becomes a very real possibility.
From above the Earth's atmosphere, IRAS will scan the skies at 4 infrared wavelengths that are much longer than the human eye can see. Dr. Matson described why these infrared detection capabilities will be advantageous.
The asteroids are, like the other planets in the solar system, are illuminated by the sun, and they absorb a certain amount of sunlight, and this is converted into heat on their surface, and this heat is then radiated away in the infrared region. They are also glowing, but their glow is at wavelengths that are much longer than our eye can detect. But these are wavelengths which IRAS can measure quite efficiently.
In addition to the asteroids, IRAS will also observe between 6 and 10 comets over the course of its 200-day mission. Again, Dr. Matson.
It is thought by many that comets are the most primitive objects in the solar system and may tell us the most about the early stages of the solar system and give new information relevant to how some of the planets were formed.
The Infrared Astronomical Satellite, enhancing investigative capabilities in solar system exploration. This has been The Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration.
NASA Special Report number 2:18. 14 minutes, 30 seconds. 3, 2, 1.
Accounts of spectacular comets are found in the histories of virtually all ancient civilizations. The first recorded apparition of Comet Halley comes from China, way back in 240 BC. Since that time, it has been observed and recorded continuously at intervals that range from 75 to 79 years. It is sometimes called Mark Twain's Comet. Mark Twain was born in 1835 when the comet appeared, and he correctly predicted in his books that he would die in 1910 when Comet Halley would come back. In a moment, a look ahead at 1986, when Comet Halley makes its next closest approach to the Sun. NASA, the National Aeronautics and Space Administration, presents a special report on Comet Halley and plans on its return. Scientists around the world are anxiously waiting for Comet Halley to return. A network of thousands of observers, both professional and amateur astronomers, will be participating in NASA's International Halley Watch, an effort to coordinate and archive observations of the comet. Dr. Donald Yeomans, an astronomer from NASA's Jet Propulsion Laboratory in California, said that observers from the Soviet Union, Japan, Europe, Asia, South America, North America, and every country which has an observatory will participate.
Yes, scientists from all over the world are participating in the International Halley Watch. It is truly an international organization. There's 7 observing networks within the International Halley Watch, and each person in charge of these 7 networks has a group of observers who he is in contact with, and he or she is charged with setting up observing standards, special days on which everyone is supposed to observe the comet in a similar technique so they can compare their observations. And then the 7 discipline specialists will send all of their data into the International Halley Watch headquarters at the Jet Propulsion Laboratory in Pasadena, where it will be further intercompared with the other observations. And finally, in 1989, we hope to have a giant archive of data, raw data, published so that future scientists can look at the data, have access to it, and make their analysis in the future.
A comet is a fascinating thing. It has the appearance of a giant fuzzy star about the size of a full moon. Its long tail spreads out, pointing away from the sun. In 1910, Comet Halley had a tail that extended 120 degrees in length.
In fact, the ancients used to call them broom stars because they looked like a fuzzy star with this broom hanging off the back. Or bearded stars. They used to call them bearded stars as well because it looked like nothing they had ever seen before. And that's part of the reason that comets have been feared for so long, is that they appear without warning. They don't look like anything we're used to. And their paths are rather strange as well because they don't follow the same paths as do the planets. And for the longest time, people thought, as did Aristotle, that comets were not celestial objects at all. They were simply atmospheric phenomena, like a rainbow or a cloud, and although much more fearful because they didn't understand them at all, and they appeared so infrequently. And the notion grew that perhaps these were messages from God. These were messages sent from an angry God to warn a sinful earth that they had better repent. And this is exactly how comets were viewed through the Middle Ages. They were warning signs from an angry God that something horrible was about to happen. Either a plague was about to break out or a city was about to burn. And we even saw some evidence of this when Comet Kohoutek came back not too long ago. There was a group out here, naturally in California, that predicted that New York was going to be destroyed by the comet. Fortunately, it wasn't.
Dr. Yeomans has been studying ancient observations of comets to see which ones actually match up with Comet Halley.
It turns out that the first confirmed observations of Comet Halley were in 240 BC by the Chinese, who observed the skies rather regularly for astrological purposes. They were charged with monitoring the skies to make sure that their rulers knew just exactly what was happening so they could make appropriate astrological predictions. But the comet has been observed at every apparition since 87 BC, right through till 1910, and it appeared a number of times to be very, very bright because it came very close to the Earth. One of those times was in 837 AD, when the comet actually appeared to be 90 degrees in the sky. That's from the horizon all the way to the directly overhead. It must have been enormous in extent, but that's because it was so close to the Earth. Not that the comet was actually bigger or intrinsically brighter that year. It just came very, very close to the Earth and scared the medieval populace.
Medieval people were not the only ones terrified of Comet Halley. Back in 1910, scientists said that it would come so close that its tail would actually sweep past the Earth.
That didn't raise too much of a fuss until somebody else pointed out that the tail was made up of cyanogen, which is an odorless, colorless, and very poisonous gas. And so you can imagine, you've got the two events here. You've got the cometary tail swooping past the Earth, and you've got poisonous gas in the tail. And so there's a lot of concern in 1910 of just what would happen when the comet's tail passed by the Earth on May 18th, 1910 was the date. And the churches were crowded as the date approached. Some people actually committed suicide.
Throughout history, Comet Halley marked certain important events, so it was easily associated with all sorts of things. Terrestrial phenomena, rainbow-like phenomenon, a messenger from God. In the 19th century, people thought it was a cloud of dust flying around the sun.
That's one of the beauties of working on comets. There's such strange things go on in the past concerning comets, and such clever anecdotes, and we know so little about comets. So people can, with the lack of data, people can make up almost any theory they like. Whereas if you have a lot of data, there's usually only one good theory that will explain all the data. But if you have only a couple of data points, you can make up almost any theory you want, and that's just exactly what's happened with comets. Nowadays, we feel that comets are a dirty ice ball, kilometer or 1 mile in diameter sized ice ball, mostly water ice, with embedded cosmic dust particles. And as this giant ice ball comes close to the sun, the gases start vaporizing, and they release the dust particles, and the light from the sun pushes the dust particles back into the tail. And that's mostly why we see a comet, is sunlight reflected off of the little tiny dust particles. And also, comets have their own light, of course. Some of the gases that are ionized from the original gases from the vaporizing ices actually fluoresce, much like our fluorescent light fluoresce. So there's two components of a comet's light, the reflected sunlight and this fluorescence of the atmospheric gases.
Comets travel around the sun, much like our own planets do, except that they travel in much elongated, cigar-shaped orbits, so we only see them when they get close to the sun, because that's the only time when they start outgassing. Otherwise, they're just frozen bits of material out on the edge of the solar system. Dr. Yeomans explained why it is extremely important for scientists to understand comets.
Well, comets are one of the few objects in the solar system that remain completely primitive, in that when the solar system formed 4.5 billion years ago from the solar nebula, or the primordial soup, the planets condensed out, the sun condensed out, and the comets condensed out. And then the comets were kicked out into the deep freeze of space for so long that their chemical mixture didn't change. Whereas the planets, there was erosion processes, there's volcanoes that distributed the mass of the planet and changed the chemical mixture of the inner planets. And so, because comets have remained in the deep freeze of space so long, they still retain the original composition from which the solar system was formed. And that's why they're so important. We'd like to find out just exactly what was the makeup of this primordial soup from which the planet originally formed.
Comet Halley is not only predictable, we know when it's coming back, but it's also bright and very active, so it shows the outgassing, the jet phenomena, the long tails that are usually associated with a cometary apparition. So it is the only comet which is both active and predictable. This is why it's important, and why this enormous effort is being initiated by NASA.
Well, I think it's fair to say with the coming return of Comet Halley and the activities of the International Halley Watch, plus the 5 spacecraft that are flying past, I think we'll know more about comets at the end of 1986 than we ever knew before. We'll know, for example, the 5 spacecraft should tell us what the nucleus of the comet looks like. Is it, in fact, an ice ball? What size is it? What shape is it? How dark is it? What is the concentration of dust and gas near the nucleus? So the spacecraft observations will really tell us a great deal about the nucleus of the comet, which we can never see from the ground because of this atmosphere which surrounded it. On the other hand, at the same time that these spacecraft are flying past, we're going to have this group of ground-based observers organized by the International Halley Watch who will be providing additional data on the atmosphere of the comet and just what the tail structures are looking like, and the atmosphere is looking like at the same time these spacecraft are flying right through the center of it. So we'll not only have the spacecraft data, we'll also have this enormous amount of data from the ground, from the Earth, which we can correlate and compare with the spacecraft data. And so it'll be sort of a synergism there. Each flight project will be helped by the ground-based observations of the International Halley Watch and vice versa.
In 1984, the Soviet Union will launch 2 identical spacecraft. They will fly by the planet Venus in mid-1985, and then both of them will continue on and fly past Comet Halley in 1986. Both of them have onboard imaging capabilities, television cameras taking pictures of the nucleus.
There'll be 2 spacecraft from the Japanese, so-called Planet A spacecraft, and another spacecraft that will be primarily looking at the ultraviolet region of our spectrum in hopes of seeing the giant hydrogen cloud that surrounds most comets. And also there's another spacecraft from the European Space Agency called Giotto that will be flying past the comet on March 13th, 1986. That also will have excellent imaging capability in hopes of determining just what this central nucleus looks like and how it is acting as a function of time. It's really quite an extraordinary thing. We've got 5 different spacecraft all flying by the comet at approximately the same time. It's an event that's unprecedented from an international point of view.
The Soviet Union spacecraft and the European Space Agency spacecraft will be looking mostly at the central nucleus of the comet.
And the International Halley Watch will be observing from the ground, and of course they won't be able to see the nucleus because of this intervening atmosphere that surrounds the comet, but they will be able to observe the large-scale phenomena that's taking place at the same time these spacecraft are looking at this very small-scale phenomena of the nucleus itself. So the ground-based observers will say what the big picture is. What is the tail structured and the atmosphere doing at the same time as these spacecraft take very close-up pictures of the very tiny nucleus. And so the spacecraft will get the small pictures of the very small nucleus, and the ground-based observers through the International Halley Watch will be seeing what the big picture is at the same time, and together we should get a very complete view of what the cometary phenomena is, at least for Comet Halley.
NASA, the National Aeronautics and Space Administration, has presented a special report on Comet Halley and plans on its return.